Hello students, in this video I am going to teach the fundamentals of factorization, also different methods of factorization. First we will discuss theoretical concept in factorization. What is the meaning of factor? When an algebraic expression can be written as a product of two or more expressions, then each of this expression is called factor of the given expression. Each of this expression is called factor of the given expression. And what is the meaning of factorization? The process of finding two or more expression whose product is given expression is called factorization. So what is the meaning of factor and what is the meaning of factorization, and what is the difference between factorization and multiplication? Both are reverse process. Both are reverse process. That is, factorization is a reverse process of multiplication. I will give a small example. This is 7x into 5x minus 7y equal to 7 into 5x, 35x square, 7x into minus 7y minus 49xy. If you write in reverse order, this is factorization. 35x square minus 49x. Take the common factors. So here 35 and 49, common factor is 7, and from x square and xy common factor is x. So 7x into remaining cases. So these two are the examples for product to factorization, factorization to product. And one more expression, product x plus 4 into x minus 5. If you multiply by the regular method, x square minus 5x plus 4x minus 20. Minus 5x plus 4x is x square minus x minus 20. This is an expression. Okay. So factor to product to multiplication, and here this is polynomial to factors. So these two are the reverse process of, that is, factorization is a reverse product of multiplication and multiplication is a reverse process of factorization. Now I am going to teach a few different types of factorization. Now first type of factorization, taking out a monomial common factor. Factorization when a common monomial factors occurs in each term. Common monomial factor in each term. If you take this expression, algebraic expression, first identify whether any common factor with respect to the number is there. Yes, 2 and 16, the common factor is 2. And with respect to variable x and x square, the common factor is x. So what are the remaining factors? From 2x taken outside, so this is 1, and from 16x square, this is 8, and from x square x taken outside. This is one of the example for common monomial factor. And one more example, 4, 12 and 8, the common factor is 4. And x cube x square, the common factor is x. So what are the remaining factors? From 4x taken outside, so 1, and plus 12x cube, 4x taken outside, so 3x square, and from 8x square 4x taken outside, so and hence plus 2. So the first concept, taking out common monomial factor. And next, factorization when binomial common factor is there. Last concept, common monomial factor, now common binomial factor. Find the common binomial. That is, if you identify these two terms, the first this is common binomial factor. Okay, other than 3x minus y, there is no common factor. So first take outside 3x minus y into the remaining factors. So what are the remaining factors? In the first term, the remaining factor is 2x, and in the second term, the remaining factor is 5y. So these two terms, 3x minus 5y, is a common binomial factor. And another example, 2x minus y into 3a plus b plus a plus b into 2x minus y. Identify the common binomial factor. Yes, the common binomial factor is 2x minus 3y. So take that common binomial factor 2x minus y into other factors. What are the other factors? In the first term it is 3a plus b, and in the second term it is a plus b. Now simplify this new expression, 2x minus y into 3a plus a, 4a, and b plus b, 2b. So another example for common binomial factor. This is type 2. So what is type 2? Taking out common binomial factor. And what is type 1? Taking out common monomial factor. Now this is second type of factorization, method of grouping. Previously taking out common factor, either monomial or binomial. Now method of grouping. So here see the a given expression, it has 4 terms. Take 10 to 20 seconds, identify which concept is applicable. For example, here you can't apply the previous concept, taking out common factor, because here x is there, x is there, x is there, but there is no x here. But if you look at third and fourth term, it has the common coefficients. Okay, so totally 4 terms are there. Grouping, group 2 terms in each case. So this first 2 terms, the common factor is x, the remaining factors are x plus y. And second to third and fourth term, the common factor is, first I will write group wise x square plus xy, one group, another group 4x plus 4y. Okay, and what is the next term here? Take x from the first group and 4 from the second group, x into x plus y plus 4 into x plus y. Now if you look at this expression, it involves the previous concept, taking out binomial common factor. So what is a binomial common factor? What is a binomial common factor? The binomial common factor is x plus y. So what are the remaining values? X plus 4, correct? First method of grouping and then taking out binomial common factor. It involves 2 concepts. First method of grouping and taking out binomial common factor. And we will discuss this term. Again, it has 4 terms. How to group the terms? Here first 2 term one group, second 2 term one group. But here that is not possible in this case. So first 2 term there is no common factor. But you can group first and third and second and fourth. Okay. So what is first and third? A square plus AB, one group, plus what is the other group? Take minus on the third and second and fourth term, minus sign is there. So minus of what? B plus A, minus of B plus A. Okay. Now first group, yes, one common factor is there. So what is the common factor? A is the common factor. So A into A plus B minus B plus A, you can write it as A plus B, because middle sign is positive, you can write in any order. Now again apply the previous concept. One binomial common factor is there. What is that binomial common factor? A plus B. So if you take A plus B outside, that is binomial common factor outside, the remaining factors are here A and here 1 minus 1, correct? So first group first and third term, second and fourth term. First and third term A square plus AB, and second and fourth term minus sign is there, minus of B plus A. Okay. Again in the first group you can take A outside and the remaining terms are A plus B, and second term rewrite in reverse order. The whole expression, one binomial common factor is that binomial common factor is A plus B. Taking out A plus B, the remaining terms are A minus 1. Okay. This is one of the very good example for method of grouping and taking out binomial common factor. Now, so far we discussed 2 techniques. One is taking out common factor, another one is method of grouping. In taking out 2 common factor, we have 2 different types of problem. Problem number 1 is taking out monomial common factor from each term, and second type problem is taking out binomial common factor with each term. Okay. And second type is method of grouping. So this is one of the very important exercise in 8th standard. So first concept is first exercise based on 2 concepts, and first concept based on 2 different types of problems. Now at present you can clear in these 2 concepts. So how to apply method of common factors and how to apply method of grouping. Hello students, in this video I am going to explain problems related with factorization using the identity a square minus b square equal to a plus b into a minus b. This is the identity a square minus b square equal to a plus b into a minus b. So one of the simple example, y square minus 121, you can write this as y square minus 11 square. Now apply this identity, a square minus b square equal to a plus b into a minus b. So this expression becomes y plus 11 into y minus 11. That's all. So very simple identity using the form. So when we can apply this identity, you can apply this identity only when the middle term is negative, also the powers are even powers. So here the power is 2 and hence we can directly apply this identity. Whereas in the second case, here the coefficient is coefficient of the first term is 1, but here the coefficient is 49, but that is also a square number. First rewrite this expression as a square number. So what is 49x square can be written as 7x the whole square. Clear? 7x the whole square, and 16y square can be written as 4y the whole square. Clear now? 7x the whole square minus 4y the whole square. So which is equal to, now again apply this identity because this is in the form of a square minus b square. So what is the formula? A plus b into a minus b. What is a? This is a and this is b, correct? So 7x plus 4y, and here 7x minus 4y. 7x plus 4y into 7x minus 4y. So here the coefficients are other than 1, but here the coefficient is 1. Whenever the coefficient is other than 1, but here both the numbers are square numbers, you can write this expression like this, 7x the whole square and 4y the whole square. Okay, and this is direct sum. And next sum using these two identities, a plus b whole square equal to a square plus 2ab plus b square. If RHS is given, how to convert into LHS, and here also RHS is given, how to convert into LHS. Here the first term is x square plus 12x plus 36. X square plus 12x plus 36. Actually, look at this term 1 and term 3, both are square numbers. Whenever first and third term are square numbers, or any three out of 3 terms, if any 2 terms are square numbers, we can apply this identity in the reverse order. So you can write this as a square, here this is b square. So what is a? Here x, and what is this? This is 6 square. So a square over b square over. Now what is the formula in between? What is the term? Plus sign, and we need this 2ab. Yes, you can write twice of ab. What is a? A is x, and what is b? This is b. B is 6. Now check at the value of this x square, 2 into 6, 12x and plus 36. Therefore, you can write this as a plus b the whole square, that is x plus 6 the whole square. Clear now? We can apply this identity only when 2 terms are square numbers. Yeah, these 2 are square number, and hence one is a square, another one is b square. So what is the middle term? Middle term is 2ab, 2 into a. How to identify a? The first term is a and second term is b. Therefore, x plus 6 the whole square. Okay, and what about this question? You can write second expression, x square minus 20x plus 100. Again, these 2 are the square number. So write a square, and here another number is b square. So x square, you can write it as x the whole square, and 100 can be written as 10 square, and middle sign is minus. Okay, now we need this expression minus 2ab. Okay, already we got an x value of a square and b square. Now minus 2ab, minus 2 into x into, sorry, a into b. So what is a? A is x, and what is b? B is 10. Now look at this, x the whole square is x square, and minus 20x plus 100. Therefore, this is x minus 10, x minus 10 the whole square, that is a minus b the whole square. We can apply this identity only when, don't forget this condition, only when 2 numbers are square numbers, and compulsory the third number is always what? Either 2ab or minus 2ab, it depends upon the middle sign. Okay. So far we discussed 2 types. Type 1 is problems related with a square minus b square, and type 2 is problems related with the basic identities 1 and 2. A square plus 2ab plus b square is a plus b whole square, and a square minus 2ab plus b square equal to a minus b whole square. So in our digital course we have tough sums using both the identities are there, but this is level 1 problems, and then we are discussing only the basic questions. Okay. So now we have Second, third technique. What is the third technique? Two different types of expression. One expression is in terms of a square minus b square. If an expression is in terms of a square minus b square, we can apply the identity a plus b into a minus b. And second model problem is a square plus 2ab plus b square equal to a plus b whole square, or a square minus 2ab plus b square equal to a minus b whole square. So far we discussed 4 concepts. So in this video, so we discussed 2 concepts. One is in terms of a square. Concept number 1 is a square minus b square, and another type is a square plus 2ab plus b square and a square minus 2ab plus b square. Okay. So now you know very good examples for how to use these 2 identities to prove the problems. Thank you. Last video I discussed using identities how to factorize trinomial, but all the trinomials are not possible to apply that identities. So when we can apply splitting the middle term, whenever if the problem is not related with a plus b whole square or a minus b whole square, then the only possibility is you have to apply splitting the middle term. So what is the concept of splitting the middle term? Suppose if original expression is like this, x square plus px plus q, and here sum is equal to the factorization of this expression, we can find 2 numbers a and b such that a plus b equal to p, that is sum equal to p and product equal to q, For example, here x square plus x minus 56, x square plus x minus 56. Here if you compare with the ax square plus bx plus c, so what is a equal to 1, what is b equal to 1, and what is c equal to minus 56. Okay. Now what is sum? Sum equal to b. So b equal to 1, and what is the product? AC. AC means product of these 2, minus 56. Sum equal to 1, product is minus 56. Factorize 56 into 2 numbers, okay, whose difference is 1. So that very simple technique. If the difference is 1, means both the factors are consecutive numbers. So what are the which consecutive numbers multiplication is 56? Yes, 7 8s are 56. 8 7s are 56. But one important condition here, minus sign is there, here plus sign is there. So very important tips, whenever the sum is positive sign, the larger factor should contain positive sign. The larger factor depends on the sign of the sum. Here it is plus, and hence this is also plus, therefore it is minus. So we can split this middle term x square, this plus x can be split into 8x minus 7x. Why 8x minus 7x? Because of these 2 factors, 8x minus 7x minus 56. Okay. Now see, the advantage of splitting the middle term is the given expression has only 3 terms. It is a trinomial. Convert into 4 terms by using the concept of splitting the middle term. Split the middle term into 2 parts, so that we will get 4 terms. Now apply method of grouping. The first 2 terms, what is the common factor? The common factor is x and x plus 8. The same factor should come here, x plus 8. So what is the remaining factor? From 7 minus 7x, x taken outside, therefore take minus 7 outside. Correct? Now this is x plus 8 into x minus 7, x plus 8 into x minus 7. So trinomial converted into, that is 3 terms, an expression which contains 3 terms converted into 4 terms, and apply the method of grouping, taking common factor from the first 2 terms, here x into x plus 8, and see whatever the expression in the first term, same expression should come in the second group. So x plus 8 outside, here x taken outside, from minus 7x, if you take x outside, the remaining factor is minus 7. Now take the binomial common factor, x plus 8, the remaining factors are x and minus 7. So this is one of the simple example for splitting the middle term concept. Okay, but here the coefficient of x square is what? The coefficient of x square is 1. Suppose if the coefficient of x square is other than 1, see here 6x square plus 7x minus 3, 6x square minus 7x. So as usual, what is the sum and what is the product? Sum is nothing but a and product is nothing but sum is nothing but B and product is AC. So what is B here? B is 7. And what is AC? 6 into minus 3. See here, 6 into minus 3, minus 18. Factorize minus 18 so that the sum is 7. Sum is 7. So 18 we have 3 into 6, but 3 plus 6, 9, but here it is 7. So 9 into 2, 18. Yes, 9 into 2, 18. But here the sum is positive. As we already discussed, sign of the sum is always for the same sign for the larger factor. The sign of larger factor is similar to sign of the sum. Here the sum is positive and hence larger factor is positive. Therefore, the other factor is negative. 9 into minus 2, minus 18, and 9 minus 2 is plus 7. Therefore, this expression, trinomial expression converted into 4 terms. An expression which has 3 terms converted into 4 terms. So what is the first term? As it is, the 7x can be split into 9x minus 2x minus 3. Okay. Now this becomes 4 term expression. The first 2 term take the common factor. So what is the common factor in the first 2 term? 3x is a common factor. 6 and 9, 3 is a common factor, and x square x is a common factor. Write the remaining factor. So what are the remaining factor? From the first term x and from the second term it is 3. Correct. Now write the same expression here, x plus 3 into, if you take x outside, the remaining value is minus 2. So now take the binomial common factor. So what is the binomial common factor here? X plus 3 into 3x minus 2. X plus 3 into 3x minus 2. So this is an example for splitting the middle term when the coefficient of x square is other than 1. Coefficient of x square is other than. Previous question is coefficient of x square equal to 1. Okay. So in this video we discussed 4 different problems, 2 different concepts. Concept number 1, trinomial expression converted into either a plus b the whole square or a minus b the whole square. So when we can apply these 2 identities? Only when 2 terms are square numbers and the middle term is in the form of 2ab. And if this condition is not possible, then we have the only concept called splitting the middle term. In the splitting the middle term, we have 2 different types of problem. One is the coefficient of x square is 1, another one is the coefficient of x square is other than 1. Now you know very well about how to apply splitting the middle term concept and also how to apply the identities. Hello students, in this video I am going to explain the concept of division, different types of expression. One is monomial by monomial, another one is polynomial by monomial, another one is polynomial by binomial, and polynomial by trinomial. We will discuss different types of problem. Start with the basic concept of monomial by monomial, division of a monomial expression by another monomial expression. But for this you need the factorization concept. So the given question is 8x square by 4x square. This is a given question, monomial by monomial, 8x square by 4x square. Now cancel the common factor wherever possible. Okay. So here x square gets cancelled, and what is the remaining value? 8 by 4, and this is 2. That's all. This is a simple example for monomial by monomial. So second question is 0.1 x square by 0.5 x cube by x cube. First cancel the variables. If you cancel this variable, this is x cube, both numerator x cube and denominator x cube gets cancelled. The remaining value is 0.1 by 0.5. If you are not comfortable in a decimal, convert into fraction. Okay, what is 0.1 is 1 by 10 and this is 5 by 10. So rewrite this is 1 by 10 and this is 10 by 5, correct. So these 2 values gets cancelled, 1 by 10. You can leave this answer as it is, or if you want to write in decimal form, 1 by 5 is nothing but multiply and divide by 2, 5 by 10, 2 by 10, which is equal to 2 by 10, which is equal to 0.2. This is 2 by 10, which is equal to 0.2. First cancel the variable, then only decimal is there. Change into fractions cancel the common factor. Again the final fraction is 1 by 10. If you want to convert into fraction, change the denominator as power of 10. So multiply and divide by 2. If you multiply and divide by 2, 2 by 10, that is equal to 0.02, 0.2. Okay. So this is a simple example for another simple example for monomial by monomial. So one more term. Here both the questions has only single variable. Now this is an example for more than one variable. Okay. So first 24 into x square into y square, this is x cube into y square by 3 into x into y. Now we just separated numbers, variable x, variable y, similarly in the denominator. Now constant wise cancel the values. If you cancel this, this is 8, correct. With respect to x, here it is, here the denominator of degree is 1 and here it is 2. So 3 minus 1, 2, correct. 3 minus 1, 2. And here the degree is 1 and degree is 2 and here it is 1. What is the final answer? The final answer is 8 and x power 2 and y power 1. X power 2, y power 1. Split into variable, constant wise, first variable, second variable. Same thing in the denominator, constant, first variable and second variable. First compare the constants, both numerator and denominator. Compare the variable x in the numerator and denominator. Similarly for y, and then cancel this value. So these three examples for the concept of what? Monomial by monomial. So next concept, polynomial by monomial. Polynomial by monomial. Now before that, is there any common factor in the numerator? Take that common factor first. So first is take minus sign outside, and any other common factor is there? Any other common factor is there? If there is any common factor, take that common factor outside. So what is the common factor in the? Otherwise we have, if you are not comfortable in common factor, split into, one more method is there, simple method, split into three terms. What is the first term? Minus q or xy by minus xyz plus second term by denominator. So how to write this expression? A plus b plus c by d equal to a by d plus b by d plus c by d. Okay, apply the same concept here. P or y z by minus x y z, and what is the last? Minus r x y z by minus x y z. Now cancel the common factors, but first, before going to cancel, first decide the sign. Here both are negative and hence it is positive. So what other terms gets cancelled? Here x x cancel and y y cancel. So qr by z plus, and plus minus, so this becomes plus into minus, minus, and what are the variables gets cancelled? Z z cancel, y y cancel. So and sign is minus pr by x. Next sign, here both are negative and hence positive, and what are the variables gets cancelled? X cancel, x cancel, y cancel, y cancel. So r z y or xyz by xyz. So this becomes what? Zz also gets cancelled. What is the final answer? The final answer is simply r. The final answer is simply r. So qr by z minus pr by x plus r. Again I will explain. Whenever numerator is polynomial, either binomial or trinomial, whatever it is, and denominator is only single term, that is a monomial, split into different terms, cancel the common factors and decide the final sign of each and every term. This is one of the very important type for division type. This is level 2 sum. Level 1 already we discussed, monomial by monomial. Level 2 polynomial by monomial. Okay. Next type, polynomial by polynomial. First we will discuss in terms of what? Binomial. See, for this question we need a previous video concept. How to simplify x square plus 4x plus 4. Whenever the given expression is trinomial, we have two concepts. One concept is we can easily apply identity Another concept is splitting the middle term. Splitting the middle term is level 2. Level 1, if possible, apply the identity. When we can apply the identity? Only when it has two square numbers. Yes, it has two square numbers. This is a square number and this is a square number, correct? So how to simplify this? This is x the whole square and 4 is 2 the whole square, correct? X square and 4 can be written as 2 square. And what is the middle value? Middle value is 2 into x into 2 by no change in the denominator. No change in the denominator. Now simplify the numerator again. So the a square plus 2ab plus b square is a plus b the whole square by x plus 2. Now how to simplify this? How to simplify this? What is a square by a cancel and this is a, and hence the first degree and this gets cancelled. The answer is x plus 2. This is very simple because of one reason is we can apply identity concept for the numerator x square plus 4x plus 4. So when we can apply identity? Only when it has two square numbers and in between is 2ab term. Okay. So this is example for polynomial by binomial. And another expression for binomial by binomial. This is an example, both are binomial by binomial, but denominator is degree 1 but numerator is degree 2 in the form of what? A square minus b square. I will teach all possible type of problems. Previous question is based on identity a plus b whole square. Now this is an example for a minus b whole square. So how to simplify this? 16m square minus 9n square by 16m square minus 9n square by 4m minus 3n. And here fix the denominator as it is, not possible to simplify, but you can write the numerator in the form of what? A square minus b square. So this is a square minus b square. What is a? A is, this is 16m, so 4m, and this is 9n, this is 3n. Apply the formula for, what is the formula for a square minus b square? A square minus b square equal to a plus b into a minus b. So this is 4m plus 3n into 4m minus 3n by 4m minus 3n. Yes, cancel both the common binomial expression. Okay. Now what is the final answer? The final answer is 4m plus 3n. This is an example for what? Binomial by binomial. Binomial by binomial. And this is simple because of one reason. You can directly apply the identity for the numerator. What is that identity? A square minus b square. One more sum. X square minus 625 y square by x plus 25y. Again denominator is degree 1, x plus 25y. So what is the numerator? X plus 25y. Numerator is a square minus b square. What is a? A is x and b. 625. 625 is a square number. Square of what? 25. Very good. So this is 25y. Now again apply the formula. X plus 25y into x minus 25y by x plus 25y. Both gets cancelled. What is the answer? X minus 25y. Previously polynomial by binomial, there that polynomial is 3 terms, an expression which contains 3 terms and 2 terms are square number, so you can directly apply the identity. Here also square of difference of even numbers, square numbers, and hence we can directly apply the identity. Okay. Next type polynomial, one of the very important and tough example. Here polynomial by binomial, but here the power is 4. Power is 4. First take the numerator, simplify using the suitable concept and then divide the concept. So factorizing 44 into x power 4 minus 5x cube minus 24x square, taking the common factor x square. So what is the numerator becomes 44 and x power 4 x cube x square is x square common, balance is x square minus 5x minus 24. Now It is a trinomial and this is not a square number. So what is the suitable concept for this? If it is a square number with positive sign, we can apply the identity, but it is not a square number and hence the only possibility is what? Yes, splitting the middle term. What is sum? Product. Sum is minus 5 and product is minus 24. Factorize minus 24 into two factors whose sum is minus 5, product is minus 24. 12 2s are not possible, 3 8s are, yes, 8 3s are. As you know the technique, whatever the sign of sum, that is same sign for the larger factor is minus 8. Now check, minus 8 into 3, minus 24, minus 8 plus 3 is minus 5. Now apply this concept, this is 44x square into x square minus 5x. This middle term split into two cases, two terms, that is minus 8x plus 3x minus 24. Now the trinomial becomes 4-term expression. Then only you can apply the splitting the middle term concept. Now grouping concept, taking out common factor. 44x square into x minus 8. This is one group and this is another group, correct? Other term, what is the common factor? Again write the expression here. So what is the pending factor? Plus 3. So what is the final expression now? 44x square into x minus 8 into x plus 3. This is the final form of a factorization of this expression, okay? Even though degree 4, we can take x square outside, it becomes quadratic expression, but not possible to apply splitting the, not possible to apply the identity, therefore apply the splitting the middle term concept. Now rewrite the question again, So this is a numerator and the value, final form of a numerator equal to, this 44 x square x minus 8 into x plus 3 by this one 11 x minus 8. Now cancel the common factors. So 11, this is 4 times, x 1, completely cancel. So what are the other values now? The remaining values. Here it is 4 and x, and that gets cancelled, x plus 3, that's all. So this is, you can expect in section D, yes, one of the very big sum. If the numerator is degree 3 or 4, wherever possible take the common factor and apply the suitable concept, either identity or splitting the middle term concept, write in product format and substitute in the given question, cancel all possible concepts, okay. So in this video we discussed different types of division problems, monomial by monomial, polynomial by monomial, binomial by binomial, now polynomial by polynomial. So this is one of the very important exercise for examination point of view. Thank you. Hello students, in this video I am going to teach in any mathematical expression how to find error and how to correct that error. Very simple exercise. The given expression is 4 into x minus 5 equal to 4x minus 5. Find the error and correct it, okay. Now what is LHS? LHS, left hand side equal to 4 into x minus 5. So what is, if you multiply by 4, 4x minus 20, 4x minus, but what is the RHS here? The RHS is 4x minus 5 and hence, so this is not possible. It is, what is the error? So correct error is, what is the correct expression now? We need only this expression, not this, okay. So what is the final, the value of the LHS is 4x minus 20, but here that the final expression is 4x minus 5, that is the error, and replace minus 5 by minus 20, correct. And second example, LHS equal to x into 3x plus 2. Now multiply term by term. If you multiply term by term, 3x square plus 2x. Now compare with this expression. Here only 2 is there, but here the final expression 2x is there. That is the error. So how to correct? What is the correct expression? The correct expression is this, and this is error expression. Okay. Replace 3x square plus 2 by 3x square plus 2x. This is an example for linear type. Now we'll discuss an expression which contains 3 or 4 terms. So what is the value? LHS equal to 5y plus 2y minus y minus 7y. So 5 plus 2 7's plus y. 5 plus 2 7, 7 plus 1 8y minus 7y, which is equal to y. So this is RHS, but here the RHS is 0 and hence the error is 0. So instead of 0, replace by what? Replace by y. Replace by y. Replaced by y, okay, because the value of the final expression is y but not 0. That is the error. Error is 0 and replace 0 by y, okay. And this expression, fourth example, expression is 2x the whole square plus 4 into 2x plus 7. Now what is 2x the whole square? 2x the whole square. 2x the whole square is 4x square plus 8x plus 7. Now compare with RHS. Constant term 7 is there, middle term 8 is there, but here only 2x square is there, but the original expression contains 4x square and hence replace 2x square by 4x square. That is an error, okay. So this is an example for quadratic and this is with 3 terms and it has 4 terms. Now rational expression type question, 4x plus 5 by 4x equal to 5. How to simplify this? Both the problems contains monomial in the denominator. Whenever the denominator is monomial, what is the working rule? Already we discussed. Yes, whenever the denominator contains only monomial and numerator is either binomial or trinomial or polynomial, split into different terms. So what is the working rule here? 4x plus 5 by 4x equal to 4x by 4x plus 5 by 4x. These two gets cancelled. So 1 plus 5 by 4x, but here only 5 is there. So the original expression is 1 plus 5 by 4x, but not 5. So that is an error. And here how to simplify this? Write the expression 7x plus 5 by 5. So as for the concept, split into 2 terms. So 7x by 5 plus 5 by 5. So what is the answer? 7x by 5 plus 1, but here only 7x is there, so that is an error, but original expression is 7x by 5 plus 1, okay. So very important chapter, factorization. It has 4 exercises. All the 4 exercises are discussed with all possible type of questions. Thank you.